Hello guys and welcome back. In this video I wanted to talk about something called cross product, which is a math operation that you can do between two vectors to generate a new vector. And this is something that I use a lot, so we're going to be using that to create a variety of effects. So let's say we have a vector called n that starts at point 0 and travels this direction. And we want to generate a vector based off of this that is always perpendicular. So if we have multiple points pointing this way, let's say another one, we want to create the cross product or a perpendicular vector to this. But in order to have to generate that, we need a second information, and that second information is called an up vector. We need to provide this our system or the cross product two vectors to be able to build a virtual plane off of that, and then generate and then compute the vertical product, the vertical vector or the perpendicular vector to that. So let's say these are our normals. We give them what we call an up vector, which is simply pointing up. It's 0, 1, 0. This is the up vector. Okay. Same for this. It's going to have an up vector like this, and it's going to have an up vector like this. Now with this information, we can construct a plane. This is our plane. Each one of these guys can construct now a virtual plane. Okay. With that, we can easily compute the perpendicular vector to this plane, and that is called the cross product, and that's how the cross product is computed. This one will be facing us, and this one will be facing this way. The cross product has a magnitude that is driven by the length or the magnitude of these two, and we have to keep that in mind when we do any processing with the cross product. So for example, let's do something in Houdini, and let me open a new session. I'm still using 3.3, 16.5.3.3. I'll switch when we get to the UV part. There's no changes that I'm interested in at this point. So let's create the toy. And let me turn off the shading. And let's compute the normals using the facet node. So now each point has normal. Let me scale this super quick so the normals are smaller. Okay. So you can see we have a normal, and this is perpendicular to the plane that we have here. We want to compute the cross product to that. Well, what's going to do? Let's say we have this normal and we give it an up vector. The plane is going to be here. Imagine this is the up vector. This is the normal. This is the up vector. It's going to construct the plane this way, and then the cross product will be facing this direction here. And I don't want to overcomplicate things, but you would ask, how does it determine the orientation? It's a right-handed orientation, and it's a clockwise orientation, or right-handed. You can do some Google if you want to learn more about that, but for now we don't have to worry about any of this. So let's create a point VOP and compute this cross product. And it's very simple. Cross product is the node. We're going to take n, and we're going to leave it as it is. Right now it's set to 0, 1, 0, which is our up vector that we agreed to use. Can be anything really. It's just it's common to use the n. So let's connect that back to the normals and see what happened. You can see we have a vector that is following the surface orientation, and that's the cross product result between the normals and the up vector. And this is very powerful because we can get the direction. Now let's say we change this, okay, to point to the up, to the Z. We get a different orientation. We can do it with the Z, with the X, and we get different orientation. So that's how it works. And this is also very important when it comes to curves, because that's what I'm going to be using it for. So let me draw a curve. Okay, and let me change it to Bezier, and let's resample it. I want a lot of points. Okay, it's a lot of points. That's too much. Yeah, something like that. And then we can compute something called the tangent, which is basically a vector that starts from one point and ends on another. So we'll get a vector that follows this. Okay, so let's do that. Let's create a polyframe node to compute this vector. It's called tangent. I'm going to simply plug it into n. So I want to store this result into n. I think by now everyone knows this. The vectors are small. It's hard to see them. So I'm going to delete the points to be able to visualize this clearly here. Okay, so you can see we have pardon me, a vector traveling along the curve. Let's compute the cross product of that. I'm gonna reuse the same node, and by just doing that you can see we have an orientation change from here to here, and that's because we're taking this vector, using it with the virtual up vector, and that's constructing a plane. Now let me copy something. I wanna make sure that you guys understand this. Copy to points. See now how the faces are oriented this way? The polygons are aligned along the tangent direction. If we connect them to the cross product result, see how the orientation changes? They're aligned this way. So it's very important. It's very important operation that we're going to be using a lot. Now, what we can do with this? Well, if we dive inside, now we have this cross product. We can take each point and move it along this vector. We do that by simply adding this vector to the position. So we connect both of them, plug that into P. You can see it shifted. Let's add a multiply and multiply by constant, and you can see how it's moving. We're just changing the position based on the cross product result. Cool, so I think that's pretty much it for the cross product. Let's move on to the next part. Thanks guys.